All right, so in this video, we're going to kind of like do what we did in the first half of our unit. We're going to take real world application problems. We're going to create an equation from that, and then we are going to graph that. So it's kind of a review of the first half of our unit. So if you weren't really understanding it now, hopefully we get to this mastery. So let's first look at just a review of writing equations. When we're given 2 points. So we're given the points 1, 6, 4, 9. So remember, we need to first calculate our slope. So I would do 9 minus 6 all over 4 minus 1. And so this gives me 3 over 3, which is real nice. That's going to simplify down to a slope of 1. So I'll put it in point slope form first using my first point there. You could use the second point too, doesn't matter. And I would do y minus 6 is equal to my slope of 1 times x minus 1. And I'm going to start getting this into slope-intercept form. I'll distribute the 1. So that just gives me 1x minus 1 and the y minus 6 over here. And then I'll add 6 to both sides, and I get the final answer of y equals x plus 5. So in our first example of a real-life application problem, we got a cab company charges a $3 boarding rate. In addition, I'm going to double underline addition because that to me is a trigger word for an operation, obviously, of adding. So in addition to its meter, which is $2 for every mile driven. So what kind of an equation could we write to represent the situation? Well, let's talk about defining our variables first. We're going to have x and y. We've got two things we're comparing here, right? I would say we're comparing a charge, like your total, and the amount of miles that we drive. So let's make x the miles driven. Sorry about that. So miles driven. And y will be our total cost. So our miles that we drive affect our cost. So that makes sense that it would be our x and on our independent axis. And let's see, so we have an initial fee of $3. Like the immediate that you get into the car, you might not even go anywhere, you immediately have to pay $3. So I'm going to say my total cost is equal to, well, that initial charge of $3 plus $2 per mile. So that would be my equation there. And now I can go ahead and graph. So I'm going to make my x-axis the miles driven. And we'll make the y-axis the total cost. So one of the things I know is the hardest thing to do is to determine, well, how does my graph go up? I'm going to make my x-axis go up by ones, just because I could drive 1 mile, 2 miles, 3. I don't think I'm going to go up very fast. Now, to determine how much my y-axis goes up by, I almost always determine that based on the slope. So my slope is 2. So my initial thought is, okay, I'm going to go up by 2s. You could make the argument that that might be difficult because my y-intercept is 3. So what I can do is I can actually just go up by ones. So I'll do 1, 2, 3, 4, 5. I think this will go all the way up to 10. So I may not be able to get as many points as I want, but it'll work. My y-intercept's at 3, so that's where I start. And then every mile is $2, right? So that makes my slope 2. So go up 2 and over 1, up 2 over 1, up 2 over 1. And so I get 4 points, and that's enough. Not exactly the best straight line. So I graphed it. I have my labels. That was one of the biggest forgetful things on the test. You always want to label your graphs. So now we can go ahead and answer part C. Well, how much does it cost to ride in the cab for, I can't see it on my thing here, it's blocking, for a minute. Okay, so if I'm going to check for a minute, I'm looking at the ones here on my x-axis. Here's 1. I don't think it meant minute. I think that's a typo. That should be for a mile. So in fact, let's go ahead and cross this out. Not for a minute, for a mile, because we're not getting charged per minute, right? We're getting charged per mile. So at 1 mile, what's my cost? $5. So that's what I'll write, $5. And we can even write it as in a sentence, right? For 1 mile. What does the slope of the line represent? Let's be specific. The slope represents that you are charged $2 per mile. Not that the cost is necessarily going up. I mean, it is. But it's just every mile I drive, I can charge an extra $2. And so then what does the 0.39 represent? Well, that represents that after driving 3 miles, my total is $9. It's actually not too bad. All right, so why don't you guys try the next one? This isn't something you haven't seen before. So try writing an equation and then check back if you have the equation right. And then try graphing and compare it to my graph and so on. So Sam is awful at keeping plants alive. The death of a plant over time can be modeled by a linear equation. It's kind of sad. The plant that Sam bought started off at a height of 60 centimeters. The gardener said that it lost 5 centimeters every month. Okay, so I'm going to kind of double underline the word lost, because to me that means we have an operation of subtraction of 5 centimeters every month. So something that's happening over and over again requires a variable next to it. So your equation would be y equals its starting height of 60 minus 5, was it 5? Yeah, 5 centimeters every month. And I'm going to define my variables. So y is going to be the height of the plant, and x is going to represent the months. So when we go to graph this, I'm going to make my x-intercept the months, and almost always, I don't want to say every time, but almost every time, I can just go up by ones when it talks about months. 7, 8, 9, and 10. Okay, now when I'm graphing the y-intercept, or the y-axis I should say, that is the height of the plant. And remember it starts at 60. So I have to keep in mind that my graph needs to fit 60, right? Because that's my y-intercept. And then it's losing 5 centimeters every month. So maybe I want to go down by 5s. And so, let's see, let me zoom up on this. Let's see if even that will fit. So if I make the very top number 60, could it fit? So this would be, I don't think this is going to fit, because this would be 50, 40, 30, 20, yeah, and 10. That doesn't make sense. Okay, so let's kind of go backwards here. Well, I actually just went backwards. Let me erase this. There we go. Sorry. Erasing that. What I could do is put in what we call a break in the graph. So I can just say, okay, so this is breaking. That means it's almost like I'm shrinking my y-axis. We'll make this start at 10, and then we can go up by 5. 15 and 20. Let's see if that'll fit. 30. Oh, man. 40. 50. Okay, you know what? I'm going to cheat. I'm going to make this 60. Okay, because I only need that to start. So here's my starting height. And if it's decreasing every 5 centimeters per month, okay, that's just a slope essentially of down 1 and over 1, since we went up by 5s. And I'm just going to keep going until I hit my x-axis. Boom. There we go. That fits perfectly. So how long will it take until the plant is 45 centimeters tall? So let's see. I'm going to look at my y-axis. Find 45. 45 is right here. I'm going to look over to my graph. Okay, here's the point. Where is that on the x-axis? Okay, so it's going to take 3 months to reach a height of 45. What does the slope of the line represent? The slope represents let's say loss in height. And we'll say the 5 centimeters every month. And then finally, what does the 0.820 represent? That represents that after 8 months, the plant will have a height of 20. 20, what is it, centimeters? Yep, there we go. Okay, so let's look at another example. It says Sam wants to cater Buzzies. I don't even know what that is. Maybe that's like a made-up restaurant for her friend's birthday party. She wants to order thin crust pizza. Okay, so I'm kind of predicting that we're going to compare two types of pizzas here. We got thin crust pizza, which costs $12.99, and then deep dish pizza, which costs $17.99. And she spent this much money on her order. Write an equation that represents the given scenario. So right off the bat, the two things I'm comparing, okay, so that would be X and Y, is thin crust. We don't know how many she bought, and then we've got deep dish. So for this, I would say, okay, well, I don't know how many she bought of thin crust, but what I do know about thin crust is that it costs $12.99. So $12.99 times X times however many she bought. But she also bought deep dish. We don't know how many she bought, but we do know that it is a total of $17.99. And altogether, she spent $172.89. So you can see that my equation is in standard form. So let's say part B, it says, let's say her budget changed. Okay, so that's going to change my total right here. Oh, I wanted to highlight that in yellow. It's not really working out for me. We're going to change that. Sorry. So it changed to $200. So that's what I'm going to change about the equation. So I'm just going to write $12.99 X plus $17.99 Y. So now her budget's $200. So let's say if she buys 8 deep dish, how many thin crusts can she buy? Okay, so deep dish is Y, right? So I'm going to rewrite this equation with 8 in for Y. So $17.99 times 8 is equal to 200. I'm going to grab my calculator here and do, let's see, $17.99 times 8. Oops, $17.99 times 8. And that gives me $143.92. That's a lot of money for pizza. And we're going to deduct that from 200, right? We're going to subtract. So 200 minus 143.92 gives me 56.08. Okay, and all I did was I subtracted the 143 to both sides, 143.92. And so now I'll divide both sides by $12.99. Let's see how many I can get. Divided by $12.99. And we get a decimal. It's X is equal to 4.32. I'll round. Now I can't buy 0.32 of a pizza, so my answer would just be 4. 4, and we're talking thin crust. So there's my final answer. So try C on your own. It says, let's say her budget changed to $300. So it's still the same equation. We still have $12.99 plus $17.99 but now we're going to set that equal to 300. Well, now she's going to buy 9 thin crusts. So that goes in for X. How many deep dish can she buy? So then I'll go ahead and do $12.99 times 9. That's going to give me $116.91. And I'll go ahead and take that away from 300 and see what I have remaining. And that gives me $183.09. So I'll then divide both sides by 17.99. And that gives me, it's another decimal of approximately 10.18. Obviously, I can't buy 18/100ths of a pizza, and so the most I could buy would be 10 deep dish pizzas. Pizza is expensive.